Hello everyone, myself Dr. Suman Saha, Assistant Professor, Department of Chemical Engineering, Malda Institute of Technology. Today I will discuss about the properties of pure substance, like properties of the solutions under the chemical engineering thermodynamics. Okay, so we know that the thermodynamic properties of homogeneous pure substances depend only on the state of the system. The relationships developed by the uh, different properties for pure fluids are not applicable to the solutions. So based on that, it requires some modification. And then the thermodynamic properties of solution and homogeneous system consisting of more than one phase are influenced by the addition and removal of the matter. Okay, so the term solution, which includes a homogeneous mixture of two or more components present in the gas, liquid, or solid phase. Okay, and before going to state any kind of property, so we know about the intensive and extensive properties also, as well as that the pressure, temperature, and the amount of various components present, which determine the extensive state of a solution, and pressure, temperature, and composition determine the intensive state. Okay, now, for the partial molar properties, which is used to design the property of a component when it is in the mixer with one or many component. Actually, what is happening when we are going to prepare any particular solution or homogeneous solution with pure property, so at that time that pure property will lose its own identity and contribute its identity partially into the solution. So that's why it is written like the partial molar property of a particular component in a mixer, which will be contribute that partially into the solution or into the mixture. Based on that, we can say like it is the mixture property. Now, if we consider M as the any kind of extensive thermodynamic property of a solution, so at that time Mt is the total value of this extensive thermodynamic property. Okay. Now whenever it will contribute itself into the solution, so at that time actually that partial molar property will be created, and which is Mi bar is equal to delta N capital M by delta Ni at constant temperature, pressure, and number of moles of jth component is not equal to number of moles of ith component, where capital M will contribute the molar property of this extensive thermodynamic property of the solution, and N is the total number of moles of the solution. Okay, and Ni denotes the number of moles of component in the ith solution, and the value of partial molar property depends only on the composition at a given temperature and pressure. So that's why it is very required to note or to write that particular definition of mathematical expression or definition of thermodynamic partial molar property as the delta N m by delta Ni at constant temperature, pressure, and a number of moles of jth component is not equal to ith component, or is equal to delta Mt n number of moles into molar property, which will give you the total property of the system. Delta Mt by delta Ni is equal to constant temperature, pressure, and number of moles of jth component is not equal to ith component. Okay. Now, So, what will be the physical meaning of partial molar property? So, to understand the physical meaning of partial molar property, let us consider the partial molar volume, which is the simplest partial molar volume. Property to visualize. So, it is the contribution that a component in the solution makes to the total volume. So, now consider one open beaker containing a huge volume of water. Okay, so in the first figure, that beaker is containing the pure water with a huge volume. Assume that now 1 mole of water is added into the pure water. Okay, and if the same amount of water is added to the large amount of water, so at that time volume will be increased by 18 into 10 to the power minus 6 meter cube. Okay, so and this contribution will be denoted as the molar volume of pure water, because in this case, if we consider a small drop of water which is added into the pure water in a huge amount, so at that time that surrounding molecules of this pure small amount of water also will be the water. Okay, so means that 1 mole of water which is added into the pure water, at that time that surrounded molecules are also the same. So based on that, or according to that, like we can say that volume increased by 18 into 10 to the power minus 6 meter cube, for an example, will be denoted as, or will be the contribution of molar volume of pure water. Now, if the same amount of water, means the same amount of water, if we add into the another beaker which is full of pure ethanol or pure alcohol, so at that time we will observe like volume increased by the addition of pure water into the pure alcohol will be 14 into 10 to the power minus 6 meter cube, which is the actually partial molar volume of the water in pure ethanol. And the difference in the increase in volume can be explained like this, the volume occupied by a given number of water molecules depends on the molecules surrounded by them, which is already discussed just earlier. Like in the case of pure water, we can identify the pure molar volume of the water by which the volume is increasing, and whenever we are adding that same amount of water, so at that time as the water which is added, or the same amount of water which is added into the ethanol, so at that time this water will be surrounded by the other constituents, okay, or other components, or the other molecules which is actually not related with the pure alcohol or pure ethanol. Okay, so based on that, this same amount of water which is added into the pure alcohol, so at that time it will lose its own identity into the pure alcohol and will give the individual identity, or it will contribute its partial identity in the pure alcohol, which is known as the partial molar volume. So based on this definition, we can say like the partial molar properties of the component of a mixture vary with composition, because the environment of each type of molecules changes as composition will change. Okay, so like the intermolecular force also get changed, resulting in the changes in the thermodynamic properties of the solution with compositions. Like total change in the total volume is equal to change in the number of moles of water to partial molar volume of water in the alcohol. Okay, so where VW bar is the partial molar volume of water, and molar volume of water or pure water VW, which can be identified at the same temperature and pressure condition, and the increased volume in the solution of the pure alcohol, that is delta VT. Okay, and delta NW is the number of moles or the amount of water added into the pure ethanol solution or pure alcohol solution. Okay, so last equation, that will be rewritten as the VW bar is equal to delta VT bar by delta NW. Okay, now if we add the finite drop of water into the solution, so obviously one finite change in the composition may arise, that is limit delta NW tends to 0, which can be defined, it means like this particular condition can be defined as the delta VT by delta NW, which will give you the mathematical definition of partial molar volume when obviously temperature, pressure and number of moles of alcohols are constant. Okay, so in mathematical expression, from the equation number 4, we can get the mathematical expression of partial molar volume, that is VW bar is equal to delta VT or delta NW VW by delta N VW by delta NW when temperature, pressure and number of moles of ethanol or alcohol will be constant. Okay, so general form of partial molar volume, that is Vi bar. I is the ith component present in the solution, that is equal to delta Vt by delta Ni, temperature, constant temperature, constant pressure and number of moles of jth component is not equal to ith component, and it denotes the incremental change in mixer volume which occurs when a small quantity of component I or ith component in a small quantity is added at constant temperature and constant pressure condition. Also that number of moles of ith component will be not equal to number of moles of jth component. Thank you.